Hi class, this is Mrs. Juliana, and we are doing 17.2 for this lesson. So 17.2 is on similar figures. What similar figures are, and generally we talk about similar polygons. If you have a polygon or any type of shape, even a circle will work, but similar figures look something like this. All right, they're not congruent. Our whole last chapter, chapter 16, was all on congruent triangles and congruent shapes. And that meant that every side length and every angle measure were congruent. But in similar figures, instead of being congruent, what happens is you get the same shape and different size. Okay? Same shape, different size. So noticing that on these two figures, here you have a rectangle that is a rectangle shape, and here's another rectangle shape. So you probably could look at those and say, well, they look similar, they're the similar shape, but their sizes are different. So when their sizes are different, then they're not congruent because their sizes are different, their measures aren't the same, but instead they are similar. So same shape, different size. All right, and that's what similar means. And polygons, I don't know why that keeps shifting. Anyway, polygons with the same shape but different size are what we call similar. And polygons that are similar have this symbol. So if I say triangle ABC is similar to triangle DEF, then that's the symbol for it. It looks just like the top part of a congruent sign, so that's pretty cool too. That makes a lot of sense. They're not totally congruent. They are similar, but they're not congruent, so we don't have the entire congruent symbol between the two triangles. We just have the little similar symbol. So what happens, though, is if I have two triangles that are similar triangles, okay, all of the corresponding angles are going to be congruent. Just like in congruent triangles, the corresponding angles are congruent. So A, B, C, D, E, F, if that's the case, then angle A and angle B will be the same. Angle B, sorry, A and D, did I say? I can't remember, but A and D are the same measure. Angle B and angle E are the same measure, and angle C and angle F will be the same measure. So corresponding angles are congruent. Okay, but the sides are not. So remember that all the triangles that are ever made, all of their angles always add up to 180 degrees. If you cut the angles out and then you line them all up, they would make a straight line. So angles are always congruent, no matter how small or how large that triangle is, angles are always congruent, but the sides are not in similar. Though they are in congruent triangles, they're not in similar triangles. What they call them are instead proportional. Okay? What that means is, if I have a side that's 2 and a side that's 3, okay, and this side is 3, then whatever I multiply this side by to get this side, I have to multiply this side by the same thing to get that side. All right? So if it goes 2 to 3, then I would have to figure out what the other sides are. I'm going to actually make this side 2 also, and then this side will be 3. So we have a ratio of 2 to 3. And then let's say this side is, I don't know, 2/3. Let's make this side 4. Then this side would be 6. I know it doesn't look like that. But anyway, if I take side to side, side to side, and side to side, I get always the same ratio. And that's why we call it proportional. So 2 divided by 3, 2 to 3, and then 4 divided by 6 is also 2 divided by 3 because it can be simplified to 2/3, or is simplified to 2/3. So what we call that, the ratio of the corresponding sides, 2 to 3, is the scale factor. All right, we call it a scale factor because it is a multiplier and a scale ratio that will set up your ratio of sides. That means if we're missing a side, say I don't know this side right here. Where's my eraser? If I don't know that side right there, okay, let's say I don't have that side. I have no idea what it is. I can look at a side that I do know the ratio for it, 2 to 3, and 4 to 6 also is 2 to 3. And if this side is 2, then I automatically know this side has to be 3 because that is the scale factor or the scale ratio. And the scale factor, scale ratio is going to be 2 to 3, and I can guarantee that for each of the sides because they're similar triangles. All right, so if polygons are similar, then their sides and perimeters are also proportional. So that means that if I take this perimeter of this triangle, 2 plus 2 plus 4 is 8 for the perimeter, and then I know that if it's 2 to 3, 2 times 4 is 8, so 3 times 4 is 12. This has to be automatically a perimeter of 12 because the perimeter scale factor is also 2 to 3, while the sides scale factor is 2 to 3. So is 8 to 12, does that simplify to 2/3? And indeed it does. If you divide out a 4, you get 2 over 3. So perimeters and sides in similar triangles are proportional by a specific scale factor that will exist in in all the sides and in the perimeter also. All right? So the scale factor is very important. We want to find the scale factor. And the scale factor, if I go back to the triangles up here, I can say the scale factor is 2 to 3. Or what if I started with a bigger triangle and then went to the smaller triangle? I could also say it's 3 to 2. So 2/3 or 3 to 2, and it depends on which triangle I state first or that I reference first. When we're dealing with problems like this, once we know what the scale factor is, what is the scale factor? Then we can only know what the scale factor is depending on which triangle they want us to start with. And so they tell us that triangle ABC, if you see this right here, triangle ABC to DEF, that means we want a side from ABC, whatever side from ABC, over whatever side from DEF that's corresponding. And we have to do it in that order because that's the order that's given to us in the problem. So if I pick a side such as this one, okay, notice that my angles go from 1 to 2 arcs. Then I have to pick the corresponding side on the other triangle, 1 to 2 arcs. So I get corresponding sides. Just like in congruent triangles, we need correspondent sides, but now instead of for congruent triangles, we have similar triangles. And you'll note that even though the angles are the same, the sides are not. 8 is not the same as 12, even though these are corresponding sides, and it's because they're similar. So I could take 8 and divide it by 12, and then simplify it to get the scale factor. If I divide out a 4, I get 2/3, and that's your scale factor. And I have to remember that I have to take this ABC as my first number and triangle DEF as my second number because that's how it is asked in the question. So I go this triangle to this triangle, side to side, and simplified that is 2/3. Or you could say 2 to 3 as a ratio, that's fine too. But most generally, we state our scale factor as a fraction. So 8 to 12 or 2 to 3. Now you can check if you pick a different side. So say I'm going to pick this side right here where my angles are the 2 arced angle to the 3 arced angle. That would be this side right here. That's 10 to 15. And because they are similar triangles, that must also simplify to 2/3, which it does. If you divide out a 5, you get 2. Divide out a 5, you get 3. So 2/3 works for that side too. And then if I were to look at this third side here, 1 arc to 3 arc is my angles match, 1 to 3 arcs, then that ratio is 14 to 21. And if you divide out a 7, you get 2/3 again. So 2/3 will be the ratio of all 3 sides, and that's going to be our ratio between the 2 triangles. Now the next question says, what is the scale factor from triangle DEF to ABC? So that one, this next question asks us in a different order, which is fine. So that means we're going to make our triangle DEF the first triangle that we're going to list the side for, and then triangle ABC is the second triangle that we're going to list the side for. So the scale factor from triangle DEF to ABC is going to be 12 to 8 or 3 to 2. And we can just flip it. We already know it's 2 to 3 in the other direction. Now that we're going from big to little, then we're going to be using the scale factor 3 to 2. All right. So what is the ratio of the perimeter? Okay. Now we can find it. We want DEF first. So we can find it, but we're guaranteed, because of the properties of similar triangles, that it's going to be the same as the side ratio. Perimeter ratio is equal to the side ratio. Okay, so those are going to be equal. Now, if you say, oh, I don't believe you, Mrs. Juliana, then we can add up all the sides. So 12 plus 15 plus 21, 5, 6, 7, 8, 1, 2, 3, 48 is the perimeter of the big triangle, and 22 plus 10 is 32 is the perimeter of the second triangle. So if I add those all up, the perimeters all up, and then I take the DEF to ABC perimeters, I can divide out, what can you divide out of 12? Nope, I can divide out of 16. 16 into 48 is 3, and 16 into 32 is 2. So you note that their perimeter ratio is also the same. All right, so that's what we are going to be asked to understand about similar triangles. And we have another little statement here. A valid similarity statement must match corresponding angles and sides. So that's another part that we have to understand. Okay, so the angles and sides match, just like in congruent triangles. So similar is that. We're supposed to find a similarity statement for the triangles above, the ABC and the DEF. All right, so we could say triangle, and we can start with 3C. We're going to start with the little triangle C, and then 2 is B, and 1 arc is A. And that's what we set our order for, and then we have to maintain that order when we list the second triangle. So we would say triangle CBA, and we went from 3 to 2 to 1, is going to be similar. We use our similar statement to triangle FED. That's a similarity statement. And of course, there are 3 of them. You could list them in whatever order you would please, but just make sure that C and F have the same measure, B and E have the same measure, and A and D have the same measure. All right, I am going to stop the lesson now because it's getting to the 15-minute mark, and I have 2 examples left, and they will probably take longer than I have. So just go ahead and exit out of this one and do the next, watch the next video secondly. Thanks, bye.